Well, hi, good morning. Thanks so much for joining me here in my shop for what I'm pretty sure will be my last round with this guy on my bench. Today I want to focus on a critical adjustment. This one, the gain adjustment here. This is R519. In the manual it says this is pretty critical, and I've adjusted it a couple of times in accordance with the procedures laid out in the manual. Seems to have adjusted just fine. That's getting 7 volts on the meter here, 150 microvolts coming out of the generator, things reconnected back here. You know, if you don't have that signal generator or something like that, you're not going to be able to do this by the book, so to speak. And I'm not terribly impressed with how it went by the book, because it doesn't leave you with any kind of good feeling that you got it. I mean, you see the number 7 on the meter, minus 7 volts. But what are you really trying to do here is this apparently very critical adjustment. So I'm looking for more insight into what this is doing and more control over the setting of it, a better approach. Let's just think about this for a minute now. The approach that's laid out in the military manual is in a military manual. The military does not count on its members being all that smart. That's a smart thing, actually. You should not be arranging jobs for geniuses. You know, here's a good job. We'll have people do that. Of course, you'll have to find a genius for it. No. That's no way to organize anything. What they do in the military world is they make sure that things like this, when they're going to be, let's say, altered or maintained, or somebody's going to work on them, even people operating them, follow instructions that basically you can't go wrong with. It doesn't require any brain power. There's nowhere in the manual here, here's the manual for it, right? There's nowhere in this manual where it says make this adjustment and then listen to it and make a judgment of you think it's better or worse. No, it's not like that. There's no human fact. They try to remove the human factor. So that means the instructions that are written in that book are designed in a certain way. Well, you know, I'm not a military guy. There's not a war on. It's 2020, and it doesn't really matter what happens to this radio. And no one's depending on anything except for me. And if you own this radio, you're in the same boat. You got a military manual with instructions for a military environment. But here we are in our homes. And in my case, I'm lucky. I've got quite a bit of equipment here. And as you're going to see, one of the cheapest pieces of equipment reveals almost everything about this whole deal. So, cheap piece of equipment. Can you see it right here? That little box. And I think, you know, if you own one of these radios or something like this, and you're able to do what I'm going to be showing in this video, you're going to want to do it. This little guy, this SDR radio, cost me, I think, $25. So let's get going here. Just a few more things. I've got this voltmeter lead. This is for this voltmeter. This is just monitoring the ADC voltage or the diode output DC voltage. One of those two. Pretty much the same thing. I'm going to get this guy on and get him warmed up. So, you know, let's plug right in the wall here. Plug it straight in the wall. It's not on because the power bar is not on. Here we go. Here we go. So on the audio side of things, I've had a problem with this radio in my shop the whole time. You've been listening to it while I've been talking. That staticky sound, I just turned the radio on. It's not coming from the radio. Unfortunately, here, have a look at my sound stuff here. So this is basically my bench control for bench items. Change the volume, and this is the master volume control. This guy feeds into these two in stereo. And this is the radio. I'll get this thing down right now. Big hum. So what I can do here, you hear that noise right now? I can lower the master volume, knock down that noise. The noise is coming from something I've done here. I still don't understand why it's there. I can knock it way down and then bring up the radio. The noise will be mostly gone. Since we're going to be doing signal to noise, we really got to be aware of what noises we're listening to. When I do that though, the microphones are going to go off, basically. The microphone volumes are going to drop enormously. So let's do that. I'm going to bring this down until the noise you're hearing kind of fades. Okay, so I think I finally figured out how to eliminate the shop-generated noise from my audio system here. Hang on a second. Just getting all the volumes back to the way they need to be. So now I'm going to drop the volume for the radio here. Up a little higher. Yeah. Now, again, what is this noise here? I don't think it's coming from the radio at all. So I'm going to switch off. I didn't know. I'm going to switch off the radio here. There's absolutely no change to the noise. So this kind of a background noise that somehow I have to make sure the noise of the radio is above this noise. So let me turn down the volumes here because they were. Radio. We need something from the radio. So right now there's no antenna on the radio, so it makes no sound. Put the antenna on. I'm just going to touch it with my finger to get a volume check here. I'll take it back. The antenna is connected. I did connect it. Just doing too many things at once. Then up here. Oh, this is the one. So what I'm trying to find is a good listening volume for the radio. At the same time, virtually no background sound from the audio system here. I have microphones up too. Let's see if that's putting a little hiss in. Yes, it is. Okay, so during some parts of this test, we may drop the microphone volumes. Okay, in fact, man your volume controls because I would imagine volume's going to go all over the map while I'm doing this. Okay, so the whole objective now is to pay attention to the signal to noise ratio. And how do we do that? Well, I do it with our ears, but I want to try to do it as visually as possible. Kind of an ear training thing. I was fiddling around with this last night. It was a lot of fun, so I'm happy to do it again. First thing, before I do anything, I'm just going to turn that gain control. We'll see what it does. Right now the gain control is set very low. This control is set very low on this radio. Just going to loosen that. It's not much different than turning the volume up and down. Except there is no volume. Because I've got the RF gain down here. Turn the RF gain up. Okay. That's the range. That's the minimum. It doesn't shut it right off. That's the next one. There's some ABC effects going on when I'm adjusting this. Just like a fading signal going up and down. So occasionally there's that sound is. I'm pretty sure it's ABC. So what noise are they talking about? I'm going to turn the RF gain down. I'm going to turn up the volumes here on the radio. Down, going up. No, maybe this is down actually. That's what the RF gain down, it's not doing anything. Turn the RF gain up just enough so we can just hear it. still hear like a shop noise in my headphones here, so unfortunately. So this is just enough that we can hear it on the low side. It's actually quite good. You hear WWD just coming in above the noise. Turn this down, turn up the volume. Compensate with the volume control, so it sounds kind of the same volume. And then listen to the difference in the sound. It's all very, very subtle. Everything here is very, very subtle. So we're at So, the fact is, I don't really hear much difference at all between either of those two settings. So, it does warn in the manual that if you don't set this right, the performance of the radio will be way off. It'll either be too insensitive or have too much noise. Where's this noise coming from? So, it's supposed to be coming out of the IF. So what exactly are we actually increasing that? So there's, I may have this wrong, okay? I'm not the super expert on this radio. It's going to take a long time, the rest of my life, to become a good expert on this radio. So, but I understand there's 3 IF amplifiers. There's probably more. There's 3 that are controlled in terms of their gain. 2 of them are controlled with the AVC, and the 3rd one is controlled with this fixed adjustment. So you have 2 RF going up and down with the signal, and then you got this one that you manually adjust somewhere. Can you possibly do this? Holy smokes, look at the finger control. It's unbelievable. So we can set it here, or we can set it there. My thinking is, when you set it high, then the radio is that much closer to overloading. The audio is going to be louder. It's going to overload maybe your audio system, maybe the audio circuits in here. I'm not using the audio in this radio. I'm taking it off right after the detector and sending it through other stuff. But just the same, the headroom is gone. So if you turn the RF, this gain all the way down, right? So now we got this. Well, when the other signals fade out, you haven't got much of anything going on in this radio to amplify it. It could drop so low you can't hear it anymore. Okay, good volume controls, turn it up, turn it up, turn it up, it would come back. Is it coming back all noisy? It may come back with the noise of the radio with it if you do that. So having it too low ends up being too high. So, so where's the sweet spot? So I've heard everything in here. I've read on the internet. The sweet spot is having this absolutely at its minimum all the time, which is clockwise. Just keep it at the minimum. Another one is you turn it up a little bit until you can hear some noise, see some noise in a meter, see some effect somewhere or something like that. By fiddling around with the minus 7 volts, put this thing at about 3/4 of the way up, something like that. And after reading stuff, I reduced it to half, and now I've reduced it to 1/4. That's where I have it. I have it 1/4 of the way up. I got good audio systems here. I got lots of volume. I can turn up. There's lots of volume coming out the back at the diode. So, but that's what I'm kind of resolving here. Now let's take a look at all this with a little more instrumentation on board here. So this is a just setting my volume levels here. This is a piece of software I just downloaded off the internet called Visual Analyzer 2011. It's probably been updated by now. If I just click it on, what this is doing is it's analyzing the sounds going through my computer, which is my voice right now because I'm talking into a microphone. You can see it up there. But it'll also show any other sound that I'm feeding through my system, like from the radio. So if I turn the radio up, voila. So now we're gonna fool around with some sound, some noise kind of deals with the radio here. But I'm gonna stop and I'm gonna rearrange cameras. Okay, this should be a little bit better. Okay, hello, yeah. Just too many volume controls in my shop during this kind of stuff. Okay, so now I'm going to turn up the radio here. And it should really be, so we're still at 15. So the deal here is that's the signal. There's the noise. Where's the low peak? The signal and noise here, to me, are pretty much the same in my ear. Oh, there the 1000 Hz tone came through again. Now, what I'm going to do, I'm going to change the bandwidth. I have this at 4K right now. Look over here, you can see 4K right here. Just leave the plus here. Open it up. Yeah, I apologize for the volume control problems. During these kinds of things, I cannot see the volume level on the software I'm using. It's not on the screen, so I'm just guessing. So just watch now. You'll see when I turn the radio up again. 16 will be out. You'll see this curving down out around here, and then as I go 16, 8, 4, 2, and shrink it, you'll see that this slope here keeps moving inwards. Of course, that's the way it's supposed to work out here. Okay, here we go. 16. 8, 4, 32. Turn it up a bit. This is a 1 kilohertz bandwidth. It's a 100 hertz bandwidth, if you want to believe it. Holy smokes. And we can't hear anything now. Let's go back. So, you know, one of the most fundamental ways to reduce noise in a radio signal is to close the bandwidth down and exclude a bunch of noise that you don't maybe need to listen to. So your first noise control is the bandwidth selector. This radio has a great bandwidth selector. That better radios always do. So the signal itself stays the same, we're just adding more noise. So what's going on with the signal to noise ratio? I would think, oops, double the noise, half the ratio, so something like that. What about psychologically? What about what we hear? I can hear the tone from WWB just as well. And we have a lot of discrimination in our brains and our hearing. But which one's more pleasant? Clearly this is. What about a little lower? You know, for all the mechanics that are behind this knob, it's amazing the little tiny movements make a difference in this radio. So going back to the gain adjustment, how much noise were we trying to alter there? Next to nothing. Next to nothing was changing. So this is where the noise control really comes in, this radio. Let's look at this a totally different way. Switch to a different kind of. We're going to switch over to our SDR. My SDR. Okay, so on the SDR, the piece in the middle is the IF signal. So it's at 455 kilohertz. So we're at 4 kilohertz here. Let me expand the SDR screen just a little more to zoom in a little bit. Now if you can read the numbers on the screen, maybe you can, the edges of that response, I don't want to call it a curve, it doesn't look like a curve to me. It's about 453 to 458, something like that. 5350, that's about 5. This is on 4. What happens if we change it to 8? Really coming at that. You can really see that when you open the bandwidth, you really do let noise come through with the signal. This is a weak signal we're listening to also. I'm going to put a little noise in here. Let's switch to the signal generator now. So I'm going to do this with a controlled signal. We're going to play around with what are the limits of being able to hear a tone with noise happening. This is the question that we're going to try to answer here. Do it visually. So I'm on 15. I'm going to move this up to say 1575. How about that? And I've got to change my frequency here to 15. Just calibrating the output here. Oops, get that all messed up. 10 times 10, 100 microvolts. You should be able to hear that. Now, most radios have a down here now. Most radios have a curve response, kind of just curved response like that. This one has a very squarish response. It comes along and it just pretty much goes like that. And you can see this if I expand this a little more. Where'd it go? That's good enough there. Now you can see it's right on 455, by the way. So if we look at that signal, you can see a couple of sidebands. This one right here, pointing at. There's another one here. I'm not sure why this second one's here. Change the frequency, the tone, and the sidebands will spread out. And of course, what we're hearing in the radio is the difference between this frequency and this frequency, or this one and that one. This being the carrier, and this being the sideband. Well, why there's more of them here? Can only guess that this isn't a perfect 1,000. That somehow it's coming out of 1,000, 2,000, 3,000. Some kind of harmonic thing happening there. Very hard to hear because it's musical. We don't really hear it. Tune the radio a little bit. What's very interesting is how low the IF is. Turn it way down. So now you can see what the RF control is doing. I don't hear any of that. And because the gain control is so low. Quite interesting about adjusting this. I didn't notice this last time. This is all experimental for me, by the way, so hang on tight. Just wandering around at this point. So this is the noise within the IF. This is the noise outside of the IF. This also went up. This stuff out here when I crank this up high. So when I just get past this point, but before that point, this adjustment doesn't seem to affect that outside noise. Seems like there's a point where the outside noise starts taking off. Spot. Look in here. Now there's a floor of noise in there which we got to ignore. What we're hearing right now, it's this other noise. This guy over here. Now, clearly turning this up is turning up the noise. We can just turn down the volume and get back to the same thing. How is this helping finding where to set this? Well, this is what the first half does, almost nothing. After we fiddle with this, we'll tune in a fairly strong station and repeat all of this again. Hear what it really sounds like. Just let me go. get comfortable. So there's some, when you get close to the top, there's some point where everything comes up. That's very curious to me. And we're adjusting the IF amplifier. We're seeing noise outside the range of the IF. So, you know, on this basis, you would want to set it, you know, something like that. You just start to hear its effect. No more than that. Too bad, you know, we don't have the 150 microvolt signal in order to set up the scenario where we can compare what we're doing here to the 7 volt routine. So I don't know how this compares. Ultimately, this is all about what you hear. And you could see how if this was the procedure that the military used, none of these radios would be working after a year. They have to follow a far more rigid way of doing it. 7 volts on the meter. Check. This is pretty wishy-washy, isn't it? Let me crank up the signal. Right now we're working with 100 microvolts. That's actually, well, let me put it right on proper. So that's 100 microvolts. Seems kind of weak. How can that be? 100 microvolts. It still seems so weak. There's something funny here. 15070. Maybe it's because I don't have the radio tuned to it. So this is the greatest thing about the IF output. I'm watching the screen like you are as I tune this radio. And, you know, is there any question that I have it tuned in the middle right now? No. No question. It's great. Okay, so that sounds more like 100. That's 10. Here, this has to be here. And that's absolutely 10 microvolts. Okay, let's watch what happens here on the screen. I can move the camera here, can I? Here's a good angle. So, reduce the generator output. How come I'm not hearing the tone now? What did I do? I turned it off. That's why. Okay, off calibration, so you hear a tone. I'm just going to reduce it. Bump something there. Must have bumped something. So what I'm seeing is the sidebands are just disappearing into the noise at the time I can no longer hear the tone. I still hear it. I'd say it's gone now. I can't resolve it. Higher tone? Now here's an interesting thing. If you look at the waterfall display, if you look, you'll see a line right here, and another line that's more distinct over here. Those are the sideband signals. So the software, the way it works, can make them visual, to be seen, even though we can't hear them. That's pretty interesting. So now we can see them, and you can kind of hear it. Now, with this setup, what can we do to make this more easily heard? First, tune it in the middle. And that sounds a bit better. No need for all that. find it easier to hear with the open setting. Not much different. Let's give it a little more in the middle. Just micro movements of this knob are having an effect. That's really impressive. Go down one more. Okay, now signal to noise. Listening to it like this. Easier to hear. Wide open. So this 400 hertz tone, I seem to be able to hear it. It's louder on the wide open one. Interesting. Okay, let's just pick up some fairly strong station here. Fiddle with this stuff, and we'll fiddle with the gain control again. Oh, it's a little loud. Now see, I've turned down the output of the radio, and you still hear this noise. When I clipped the antenna, there was a touch of noise showed up. So just compensate her a little bit. Almost too much for my SDR. So I've been working away here for quite a while with the not realizing the volume was down. So, once again, counterintuitive to me is maybe we need to look at the screen to find this out. I can hear it better when it's wide open with all that noise coming through than I can when I stop it down. Even though stopping it down shouldn't change the tonal pitch very much, it's just the highest frequencies being thrown away. Let's try it again. We're at 16 here. As a fading signal, so So what's happening is the gain control is compensating for this wide range in settings. And the signal stronger.
Expose themselves to guilt and will be beatified. Boasting as the moon is among the stars, the sage always distinct and subduing his senses, think about beatitude, a pious man called an island, the beings which are carried away by the flood of the samsara and suffer of their guilt. His place of safety is only attained by the taking part. He who guards his soul, subdues his senses, puts his off the current of the samsara, and is free from asava, is entitled to a calm, pure, complete, unparalleled law, spiritual precept. Those who do not know this law, spiritual precepts, are not awakened, so they consider themselves awakened, feeling themselves broken, and beyond
Too far. Okay, so this weak signal, if I were interested in a double blind test, I could really do it. What's compensating this long. So, the opinion is it's way too high, normally. So I'm going to set mine fairly low. Figured out that you can get rid of the noise by doing this, but the signal for me becomes less intelligible. I'm a little bit surprised because I do this all the time. I reduce the bandwidth to try to hear things more clearly. We gotta go off in search of a strong station and do all this over again. So this is a fairly strong station. Barely moving my PCs. It's not so strong. We'll give a shot at 9330.
Although your sin be great, Christ is able to put it all away. Do not trust in Christ as sinners. You get a mingle-mangle kind of faith. You trust in Christ as though you thought Christ could do something for you. And you could do the...
Okay, so sorry this is religious, but this is what it is. So I'll try to ignore what he's saying and just listen to the sound of it. So right away you see the sideband's much more distinct on this signal because it's stronger. You can see they're all the way out. They're all the way out to the limit here of 8. I go to 16. There's even stuff out at 16. Let's listen.
And you must come to Jesus and leave your fancied righteousness and your pretended goodnesses behind you. And you must take him for everything and trust in him. Oh, to feel your sin and yet to know your righteousness. The two together. Repentance on account of sin, and you have a glorious confidence
confidence in the all-atoning sacrifice. Oh, if you can understand the saying of the spouse, I am black but comely, for that is where we must come. Black of myself, as black as hell, and yet comely, fair, lovely, inexpressibly glorious, through the righteousness of peace. My dear brethren and sisters, can you feel this?
If you cannot feel it, do you believe it? And do you sing in the words of Joseph Hart, "In thy surety thou art free. His dear hands were pierced for thee. With thy Savior's
give him the
vesture
game
and
treatment here.
holy as the Holy One." For so it is. You stand before God as accepted as Christ is accepted. And notwithstanding the inbred sin and corruption of your heart, you are as dear to God as Christ is dear, and as accepted in the righteousness of Christ as Christ is accepted in his own obedience. Have we got so far?
AGC.
That is the point on which I want to inquire this evening. Have you got as far as to know at this moment that it is through faith that we are justified? If so, I shall conduct you just one step further, namely to observe, and this is coming back whilst it all goes forward, that we are justified by faith through our Lord Jesus Christ. Now there is the foundation. There is the mainspring. There is the tree that bears the fruit. We are justified by faith, but not a faith of itself. A faith in itself is a place.
They don't hear any change whatsoever. So I think the lesson here is, when you're operating with a fairly strong signal and the AGC is operating, the AGC is in control more than anything. And the setting of the gain of this one stage, it just doesn't seem to have any impact on anything. My understanding is the AGC is not controlling the third IF amplifier, just that adjustment. So on that basis, in AGC mode, it's better that this be low, just because it just gives you more headroom everywhere, I would think, or just up a little bit from where it was. I think this is really about weak stations. This is the impact of this thing is all about trying to hear a weak signal. So we got to go back and find some weak signals here.
I feel this.
This one definitely doesn't qualify as a weak signal. Let's get this meter up to 50. Pushing this one right over. So I'm only on 5 volts on that one.
When you have to say, "Oh, wretched man that I am, who shall deliver?"
I noticed it doesn't matter much where I put that in the past. I like the sideband window. So there's that same effect where the fringes come up, outside the IF come up. If I turn this up too high, same effect there. Again, with the AGC on. That might be another volume control. I'm doing this. Volume's going up and down. Okay. Brother Stare, can you get clear? It's too much for the radio. Now we can't be fooled by just it getting louder. Louder always sounds better. It's a psychological fact. Louder sounds better. It's definitely distorted. Now, right at the minimum here. I have to turn the volumes up a little bit. Off the minimum. Now, there's no guarantees that my radio is working the way all these radios should. There could be something funny about mine. This RF control just seems to work at the top 10%, doesn't seem to work otherwise, unless I crank up the volume, something crazy here. Still wants to be way up here. This is the proper way to turn up the audio level high when you're using this, and then control the volume of this, keep this as minimal as possible. It's kind of where we are now. Okay, let's go with this. I'm also watching to see if there's any indication signal to noise is improving, and looking at the thing visually. I'm not sure. So trying to interface the electronic mechanical system with the biological system here. No question that more noise is way up high, way up high. And it's that shoulder thing coming. Exactly what that is like. So it looks like as long as you're, say, below 3/4 of the way up, or down 1/4 from the top, you're safe from that, at least in this radio. And the advantage of having it turned up. We're going to get some amplification out of that stage and put it up some distance. Okay, so now my thinking is that's 180, that's halfway. In more than one place, especially in the military manual, it says this adjustment is absolutely critical. And other things I read said this adjustment done wrong, it basically ruined the radio. Yeah, the radio's not going to work with. Yeah, it's going to be terrible. Well, it's not that case with my radio. You can pretty much do anything you want with this, and it's not the end of the world by any means. Yeah, when you get it up full, which might sound nice because everything's getting louder, you are bringing in more noise, no doubt about that. That seems to be, in my radio, at about a quarter turn from the top. You got to be below a quarter turn from the top, and you avoid that thing that's happening, whatever it is. Go as low as you want from there. It depends, I guess, on your audio amplification strength, how you're taking the audio out of here, depending on the radio itself, which probably many of you are. Or if you're doing what I'm doing and tapping off at the diode output and feeding it through some other amplification system. So there we are. So this guy's heading back to my listening post, and which I am improving tremendously, and I'm really quite excited about listening to this radio, my Hammerland, and other radios. Especially my plan here is when I finish repairing a radio here in my shop, it goes down to the test department where this radio is and my Hammerland is and other radios are, and in the test department it gets a really good test. That's the one thing I cannot do in my shop here, is give radios a really fair test. So when I do this, it's never on video, nobody ever sees it, and I think it must be a little bit disappointing for those of you who watch me fix a radio and then I never really sit and play it. Well, I'm getting ready to start doing that kind of thing. So there we go, R390A. I think it's working as good as I can get this guy to work, and I managed to solve a couple problems along the way and make some videos. So thanks a lot for watching, and I really do have an old 1930s radio coming in here tomorrow.